Hi everyone. So in the last class we have seen the definition of monotonic increasing sequence, monotonic decreasing sequence and monotonic sequence. So based on that, in this class let we discuss some examples based on that. Okay. So first example is prove that the sequence whose n terms given below are monotonic. Find out whether they are monotonically increasing or decreasing sequences. So first example is 1 by 2, 1 upon 2 square, 1 upon 2 to the power 3 plus 1 upon 2 to the power n. Second example is 1 by n, 1 upon n plus 1, 1 upon n plus 2 plus 1 upon 2n minus 1. Third example is 3n plus 7 divided by 4n plus 8. Fourth example is 2n plus 7 divided by 3n plus 8. So solution for first example, let an is equal to 1 by 2, 1 upon 2 square plus 1 upon 2 to the power n. So in the place of n is equal to n plus 1, so then this equation deduces like this. So that is n plus 1 is equal to 1 by 2, 1 upon 2 square plus 1 upon 2 to the power 3 plus so on 1 upon 2 to the power n plus 1. 1 upon 2 to the power n plus 1. So back term is what? 1 upon 2 to the power n. 2 to the power n. So this is 1 upon 2 to the power n plus 1. So therefore an plus 1 minus an. So an plus 1 term is what? 1 upon 2, 1 upon 2 square plus so on 1 upon 2 to the power n, 1 upon 2 to the power n plus 1 minus an is what? 1 by 2, 1 upon 2 square plus so on 1 upon 2 to the power n. So if we subtract this term using this term, so then the remaining solution is, because 1 by 2 minus 1 by 2 vanishes, 1 upon 2 square minus 1 upon 2 square vanishes, so 1 upon 2 to the power n minus 1 upon 2 to the power n vanishes. Remaining term is what? 1 upon 2 to the power n plus 1. So that implies that an plus 1 minus an is equal to what? 1 upon 2 to the power n plus 1. So your n is natural number. So therefore if you put any natural number here, so then it is strictly greater than 0. Strictly greater than 0. So that implies that n plus 1 is greater than an. So this is the definition of what? Monotonically increasing sequence. So this condition satisfying your monotonic increasing sequence. So therefore sequence an is monotonically increasing sequence. So if sequence is monotonically increasing sequence or monotonically decreasing sequence, then we can say that sequence is monotonic sequence. So second example is, let an is equal to 1 by n, 1 upon n plus 1, 1 upon n plus 2 plus 1 upon 2 to the power 1 upon 2n minus 1. So if you substitute n in the place of n is equal to n plus 1, then it will become 1 upon n plus 1. Put in the place of n is equal to n plus 1, then it is 1 upon n plus 1. So this is n plus 1 plus 1, n plus 2, n plus 1 plus 2, n plus 3, so on 1 upon 2n plus 2 minus 1. So this is 2n plus 1. So back term is, so we are raising 1. So here 1 plus 1, so plus 1, n plus 1 plus 1. So this is n plus 2, n plus 1 plus 2, n plus 3. So like that means 1 is increasing. So here, so decrease 1. So this will become 1 upon 2n. So this will become 2n minus 1. So therefore an plus 1 minus an. So your an plus 1 term is 1 upon n plus 1, 1 upon n plus 2, so on 1 upon 2n plus 1. So your an is minus 1 by n. Okay. So minus 1 upon n plus 1 plus 1 upon n plus 1. These two vanishes. So these two vanishes. These two vanishes. Left term is what? 1 upon 2n. 1 upon 2n plus 1 upon 2n plus 1 minus 1 upon n. So I use these two terms, 1 upon 2n minus 1 upon n. So using cross multiplication, I can write 1 upon 2n plus 1. So this is 1 upon 2n plus 1. So using these two, I can write minus 1 divided by 2n. Because, so minus 2n, this is n. So minus n divided by 2n square. So n goes, then left term is what? Minus 1 upon 2n. So this is equal to minus 1 divided by 2n into 2n plus 1. So if you take any natural number here, so this is less than 0 because negative term. Okay, negative term. So therefore here what we are getting, an plus 1 is less than an. So this is the condition of what? Monotonically decreasing sequence. Therefore we can say sequence an is monotonically decreasing sequence, and hence it is monotonic, because to say monotonic sequence, whether it may be monotonically increasing sequence or monotonically decreasing sequence. So third example is, let an is equal to 3n plus 7 divided by 4n plus 8. Okay, 4n plus 8. So what I am doing here, 3n plus 7, so here I am taking 4 as common. So then it will become 4 into n plus 2. 4 into n plus 2. And put in the place of n is equal to n plus 1, then we get, so 3 into n plus 1 plus 7 divided by 4 into n plus 1 plus 2. So this is 3n plus 3 plus 7, that is 3n plus 10. So 4 into n plus 3. So now what I do, therefore an plus 1 minus an is equal to 3n plus 10 divided by 4n plus 3 minus 3n plus 7 divided by 4 into n plus 2. So cross multiplication. So then we get 3n plus 4, 4. Okay, so these are common, so we multiply with n plus 2 and n plus 3. So 3n plus 10 into n plus 2, 3n plus 7 minus 3n plus 7 into n plus 3 divided by 4 into n plus 2, n plus 3. Okay, so after multiplying this, it will become 3n square plus 6n plus 10n plus 20 minus 3n square minus 9n minus 7n minus 21 divided by 4 into n plus 2, n plus 3. Okay, so then this 3n square minus 3n square, so this is 16n, so this is 16n. Okay, this is 20 minus 21, so left term is what, minus 1 divided by 4 into n plus 1, n plus 2, n plus 3. So is it greater than 0 or less than 0? Because negative number less than 0. So therefore an plus 1 minus an is less than 0 for all n. So that implies that n plus 1 is less than an. So what is the condition of, so this condition satisfying the definition of monotonically decreasing sequence. So therefore we can say this is monotonic sequence. So next example, so that is prove that the sequence whose nth terms are given, below are monotonic. Find out whether they are monotonically increasing or decreasing. So first example is 1 plus 1 divided by 1 factorial plus 1 divided by 2 factorial plus so on 1 divided by n plus 1 factorial. So second example is what, 1 divided by 2n plus 5. Third example is minus 1 divided by 2n plus 1. Fourth example is 2n plus 7. Fifth example is 1 divided by n. Sixth example is 1 plus 1 divided by 2, 1 divided by 3 plus 1, 1 divided by n. And seventh example is 1 plus 1 divided by n to the power n. So in the last class we have seen, in the last example we have seen, so how to find monotonically increasing sequence and how to find monotonically decreasing sequence. So based on that, you try to solve 1 to 6 examples. Those are homework for you. So I will try 7th example here only. So for 7th solution for 7th example, so here I am taking let an is equal to 1 plus 1 divided by n to the power n. So this is equal to, using binomial theorem, I am writing this as 1 plus nc1 1 divided by n, nc2 1 divided by n square plus so on ncn 1 divided by n to the power n. So I am writing, means nc1 is n, so that is 1 plus n into 1 divided by n plus nc2 n into n minus 1 divided by 2 factorial, that is into 1 divided by n square plus ncn n into n minus 1 n minus 2 so on 1 divided by n factorial into 1 divided by n. So see here 1, so n remaining term is what, 1. Okay, so this is n square minus n divided by 2, so into 1 divided by n square, this n square, this n square. So minus n divided by n square is what, 1 divided by n, that is 1 minus 1 divided by n. So you multiply these two terms and divide by this. So then you get 1 divided by 2 factorial into 1 minus 1 divided by n. In the similar manner, next term 1 divided by 3 factorial into 1 minus 1 divided by n, 1 minus 2 divided by n. Okay, so plus so on 1 divided by n factorial is n minus 1 terms. So that is 1 minus 1 divided by n plus 1 minus n minus 1 divided by n. So changing n to n plus 1, we get an plus 1. So this is your an. So n plus 1, 1 plus 1 plus. So in the place of n, I am replacing n plus 1. So 1 divided by 2 factorial into 1 minus 1 divided by n plus 1. 1 divided by 3 factorial into 1 minus 1 divided by n plus 1 minus into 1 minus 2 divided by n plus 1 plus so on. 1 divided by n plus 1 factorial, that is 1 divided by n factorial there in the n term. So here 1 divided by n plus 1 factorial into 1 minus 1 divided by n plus 1 plus so on. So this is n plus 1 minus 1, that is n divided by n plus 1. 1 minus n divided by n plus 1. Okay. So how to find bigger terms using these two? Okay. So now what I am taking, 1 divided by n plus 1 is less than 1 by n. Yes. Put n is equal to 1. So this is 1 divided by 2 is less than 1. Okay. So this implies that, so I am multiplying minus, then equality changes. Minus 1 divided by n plus 1 is greater than minus 1 divided by n. So this implies that 1 minus 1, so I am adding 1 both sides. So then it will become 1 minus 1 divided by n plus 1 is greater than 1 minus 1 divided by n. So generally I can write it as, similarly 1 minus k divided by n plus 1 is greater than 1 minus k divided by n. So if you put k is equal to 1, so you get first term, that is 1 minus 1 divided by n plus 1 is greater than 1 minus 1 by n. So in the similar manner, if I put k is equal to 2, then you get 1 minus 2 divided by n plus 1 is greater than 1 minus 2 divided by n. So on, k is equal to n minus 1. So it follows that, so an plus 1 is greater than equal to an. So this term becomes bigger term than this. Okay. So therefore an plus 1 is greater than an. So therefore this is the definition of what your monotonically increasing sequence. Therefore this is satisfying your monotonically increasing sequence. Therefore I can say sequence an is monotonically increasing sequence. So therefore it is monotonic sequence. So thank you. So if you have any doubts regarding these examples, so you can ask questions regarding that, or put your questions in the comment box. Thank you one and all.